Hi, I'm Eric Anderson, the General Manager of AWS Robotics, and I'm here today joined by my colleague Christine Osick, who's the Head of Simulation at Amazon Robotics, to talk about how Amazon optimizes robotics and autonomous systems with simulation. How are you doing today, Christine?
I'm doing great, Eric. Thanks for joining me here at our brand new Amazon Robotics Innovation Hub. We just opened this new facility here in Westboro this month.
It's a really amazing building. It's got a tremendous amount of innovation space. There's robots running all over the place. It's really exciting to see what you guys are producing here.
Yes, we're even manufacturing them here on site. So it's very exciting place to be.
It's tremendous, tremendous. So here today, what we'd like to talk to you about are really four things. The first is we want to introduce operations at Amazon so you understand the types of problems that Amazon has in our fulfillment and logistics network. The second is we want to talk about simulation and what types of simulations do we use at Amazon, how do we apply them. We want to do some deep dives into some Amazon-specific use cases for how simulation is used to innovate and help us build robotic systems. And then we want to talk about the AWS services that would allow you to build robotics in your applications. Before we get started, I want to just introduce the types of robotics that we have at Amazon. I'm sure everybody's aware of our fulfillment systems where we have goods to people and a dense storage system that operate our fulfillment network, but we do so much more at Amazon with robotics. We have robotic arms that are used for package manipulation. We have autonomous vehicles that we use for material movement, material handling inside of our logistics and warehousing. We have a logistics robot. I'm sure you may have seen in some metros the Scout device, which actually is doing last mile delivery to people's homes. And then, of course, we have Astro, the consumer robot that we announced recently that can move around your home and talk to you with Alexa.
Amazon uses robotics to help us scale our business and help get packages to customers sooner. Just to give you a little idea of the scale of our operations here, we have over 175 fulfillment centers worldwide. We have over 40 sort centers worldwide, and we have over 50 robotic fulfillment centers. Amongst those, there are over 350,000 robotic drive units out there of different types, and we have over 150 million square feet of fulfillment space that those drives are moving around and operating in. There's over 1 million people worldwide that are employed here to help drive our operations network.
That's tremendous, Christine. I had no idea that Amazon had such a robotic footprint. That's really amazing. If we look one level down, the complexity of ordering a product on Amazon becomes more apparent. Where is your product stored? Which fulfillment center should it be fulfilled from? How does it get where it needs to go? Does it need to go on a truck, an airplane? Where is it boxed up and packaged? And then finally, what's that last mile delivery look like? Is it done via robot? Is it done via truck? Do we actually use one of our delivery partners? There's a very complicated set of software systems that make those decisions around how those orders get turned into deliveries at your home. If we look even more one level down, inside of a particular fulfillment center, things get even more complex. How many business processes do we have? Where are we stowing product? Where are we picking product? Where are we packing product? How do we sort products in the fulfillment center? How many different robots do we need? How many different robots do we need to implement for particular types of volumes, whether it's a March day or whether it might be during our busiest holiday season? How much conveyance do we need to implement? What are the safety considerations to make sure that the people that work in the facility are actually kept safe? What are the construction costs? How do we optimize that? There's so many questions that get answered within all of these different processes.
Simulation helps us answer all those questions. As Eric said, there are so many questions that we have to answer. We use simulation to help improve those robotic operations and to help us design them. We use it for designing brand new concepts, what-if scenarios of new prototypes of new robotics or new robotic workstations. We use simulation to do system design, and it helps us identify the constraints of the system. It helps us to plan out workflows and see how we want the system to work. And then we also use simulation again when we are qualifying and testing our systems. It helps us benchmark and ensure that the system performs as it should, that it's safe, and that it meets the benchmarks that we need it to meet.
That's really great, Christine. 3 different types of simulations. I hadn't really realized that there were so many different ways in which simulations would be implemented. What we'd like to do now are really introduce 5 different use cases for how simulation will be used inside of our Amazon development process. The first is we use simulation to visualize how robots will work to non-roboticists. We'll then talk about how we use simulation to accelerate robotic solution delivery. Next, we'll talk about how simulation can be used to accelerate the development of new robotic perception systems or machine learning systems. And the fourth and fifth are very interesting in that they're applications built on top of simulation, which are used to train machine learning models or optimize robotic configurations.
Yes, in the early days of Amazon Robotics, when it was still a startup called Kiva, they were using simulation from the beginning. They used simulation to help them design the systems and test the software. They modeled the inventory going through the system. They also used the simulation to show to their customers who were unfamiliar with robotic systems how they worked and demonstrate the value of adding robotics to their operations. And they obviously did very well because Amazon saw the value in what they were doing here.
That's a really great point. I talked to a lot of startups, Christine, that use simulation or can see how simulation can be used to help them build their businesses. Robotics is oftentimes really hard to explain to a customer what it does, how it works, how it's going to be implemented at a certain environment. And I can absolutely see how a simulation like this could help visualize for a customer what they were going to get when they purchased a particular robotic solution. Really great point. The next solution that we'd like to talk about is how you can use simulation to accelerate robotic delivery. We were approached in Amazon Robotics several years ago by one of our very senior executives at Amazon with an idea. How do we turn a robot that looks like this into a robot that looks like that? And it would be completely different in terms of the type of use case. Robotics at the time were primarily a fulfillment solution in that the robots would pick up a cart or a pod, bring it to a human and pick products. What the solution was that we needed was a solution that would actually sort packages. And so you can see here what we built was a series of simulations that allowed us to design the facility, design the workflows and the software that would be used, and actually put this into production at a much accelerated pace. Typically, new robotic systems would actually take somewhere more than 2 years. This application was actually delivered in about a year from start to finish, and it actually helped us operate through one of our peak busiest seasons in the first year that it was open. This was a great application. You can see here in these video images the 3D simulations that were built, and then the actual live building that went live later that year. To do this, we actually built 2 different simulation models, a conceptual design simulation, which really helped to understand how is the system going to work end to end, and then a series of solution design simulations, which actually designed the building, determined where these chutes would be placed, determined how the software algorithms would work, basically operated the entire building in a simulation environment, which allowed us to iterate and go much faster.
Yes, Eric, that was so essential to that project that we use simulation on every single delivery now, from the concept phase all the way through delivery. It's used and it helps us adapt to changes in the design and deliver on time for our customers. We also use simulation to help design new perception systems. Designing and testing these perception systems for autonomous robotics requires the physical world environment available to those robotics. We need to be able to simulate that for the sensor models to be able to train. We also simulate to see how these autonomous vehicles are going to operate in the environments. And we also use it to see how the drives will work amongst each other, to see if, as they start moving around each other, do they cause congestion, and how can we lay out the area that they operate in better. So it's essential in autonomous robotics to have simulation for designing these perception systems.
That's really interesting, Christine. We also use simulations to actually generate data that we then use in machine learning model training. And so because simulations can be built in very high fidelity ways, meaning they very accurately represent the physical world in a virtual world, what we can do is use 3D objects to generate images that can be then used to train machine learning perception models. So you can see here on this slide, you're actually able to take a box or a bag that you might package up an Amazon product in. you can model that in 3 dimensions, and then you can use a physics-based simulation engine to render what that would actually look like when it was being presented to a robot for a pick-and-place solution on a conveyor belt. And so you can see here that those renders would come out in physically accurate ways. And then because you're aware of the actual object, the location where it's at via the simulation engine, you can then put on top of it highly accurate labeled data. So you can generate your labeled objects or your ground truth objects from a synthetic model and be able to then train your machine learning models much more quickly and much more accurately. We use this within our applications, and we work with customers who are using this in their solutions as well to use 3D objects to model rare or very complex scenarios. You can imagine even very highly random distributions of scenarios. We can generate randomized objects. You can change the size, the shape, the color, the texture programmatically. So you don't have to model all of those things in the real world. And then because this is a high fidelity simulation engine, you get very high fidelity images, meaning you're able to actually represent the same types of data in a virtual world that you would see in the physical world, which means your models that you train are going to be more accurate than what you can do with human labeled data.
That is an important use case. The other thing it's used for as well is to replay what happens in production. Once we have the data of what actually went through our facilities, we can use that synthetic data generator to recreate what was happening in the real world. Another use case we have is to optimize robotic configurations with generative design. As Eric pointed out earlier, there's a lot of software and hardware involved in our robotic solutions. And the software and hardware both rely on maps for configuration and to operate in the buildings. And we had this problem that we needed to solve, and Amazon needed to increase the amount of product stored in the existing buildings. And so we used simulation to automatically edit those maps and then run through simulations to see if they would, if we could increase the amount of storage without affecting the floor operations. And it was very successful. We were able to produce better maps faster. They were actually better maps than we could manually create. And we had no impact to our floor operations. You can see here in the picture that the drives are trying to dig out pods from that map. So we were able to make those pod areas denser. And it would require more dig outs for the drives, but it was able to, simulation proved to us that we could do this without affecting our throughput. In fact, we actually gained some throughput from some of these changes. So simulation in the loop of automatic processes is another very valuable use case for us at Amazon Robotics.
That's really interesting, Christine. I have to imagine that one of the key components of how that solution worked is that you had the actual software running in the simulation model?
Yes, we did. That is a good point. We have simulation in the loop in our simulation tools. Software in the loop in our simulation tools. And having that software in the loop enables us to test the software, but it also increases the fidelity of our simulations.
Really interesting, really interesting. So just to take some key learnings here from those use cases, I think to start off, don't make a guess, simulate. Simulation is an incredibly powerful tool that generates real data that you can use to make more informed decisions, accelerate the development of your robotic systems, and ultimately make a higher quality product.
And software in the loop is key. It helps increase the fidelity. It allows you to test the robotics and the software system at the same time with higher fidelity.
And the next point is really fidelity, fidelity, fidelity. When you're building a simulation, the number one thing you have to be aware of is what is the fidelity of the simulation, and that should be guided by the type of decision that you're making from it. It's totally okay to have a simulation that's considered low fidelity or not particularly accurate to real-world outcomes, as long as the decision that you're making can be based on that level of data. If you need to make very fine-grained algorithmic tuning, if you're training machine learning models, high fidelity simulations are going to be critical to make sure that the outcomes that you get are going to be useful from the simulation environment.
Yes, and high fidelity models and simulations, we create them with software in the loop, and we can use them to also help test the software as well. So you can embed these simulations into other applications and other tools, and we do that to improve things in our worldwide operations network.
It's really exciting stuff you're working on here, Christine. I think it's great. So what I'd like to do now is spend a few moments just talking about how you can use AWS tools and services to build simulations to help your robotic innovations go faster and be higher quality. Within AWS, we have the AWS RoboMaker service. RoboMaker is a cloud-based simulation service that enables robotic developers, really developers of any kind, to run, scale, and automate simulations without having to manage any infrastructure. RoboMaker provides 4 big use cases for customers. The first is it's a serverless container-based simulation execution system. What that means is that you can take a container-based simulation from any simulation engine. You could use Ross's Gazebo simulator. You could use Ignition. You could use Unreal or Unity. You could even use Isaac Sim. And we will build out and execute that simulation inside of RoboMaker using our container-based simulation architecture. The next solution or use case that we see customers use RoboMaker for is batch simulation. Whether you're doing generative design, reinforcement learning, or building applications like Christine was talking about earlier around optimization of different algorithms or properties, you can use RoboMaker's batch simulation capabilities to run hundreds or thousands of different variations of simulations using our APIs to be able to cost effectively deliver on those solutions. RoboMaker also provides a world building capability where we can generate hundreds of worlds for your robot to operate in, so you don't need to go through the effort to design and build out indoor worlds for your robot to navigate around. And then what we see a number of customers do is once they've incorporated their simulation engines into their software stacks, they're able to achieve a high fidelity simulation environment that they can then plug into their CI/CD workflows. RoboMaker APIs allow you to integrate your simulations into your build processes, your test processes, your qualification processes, to make sure that you're able to verify that when you're pushing new software code or new cloud-based application code that manages your robots, that you know what's going to happen once it gets into the production environment. We have a number of RoboMaker customers that have used RoboMaker to successfully deliver on their applications. Whether it's Milvus Robotics that implemented a CI/CD pipeline so that they can test robots in different environments, which has resulted in a huge quality improvement. JetBrain, which used simulation to expand and speed up the robotics development process, or Rumi, which used RoboMaker to save weeks on their development time to make it possible to test prototypes in real-world scenarios. It's best to think of simulation as a series of activities that you engage in. Whether you're deciding on what test scenarios to build or what level of simulation fidelity you need, whether you need help building your robot or your application or your simulation application, designing and building out your simulation world in which a robot is going to operate in, or even defining test cases. We can help and advise you through all of these. We've been involved in simulation for years building out RoboMaker, but we have our partners in Amazon Robotics that we work with on a regular basis to make sure that we can bring the best practices of simulation development to you as well. If you'd like to learn more, there's a series of resources that you can engage in. To learn more about fleet-based simulations, batch simulations, and more, check us out on our blog at blogs.robot/robotics. You can get hands-on with RoboMaker at some of our workshops. Visit robomakerworkshops.com, or you can learn more about AWS RoboMaker on the product page by just navigating in the console to RoboMaker. And of course, you can always contact us at the email below. We'd love to hear from you. So I'd like to thank you for attending, but I'd also especially like to thank Christine for helping me present today. I think it was really great. Thank you, Christine.
Thank you, Eric. Thanks for having me.
And I thank you all for attending, and please make sure to fill out the speaker evaluation, which will be available shortly.